Okay, we're continuing with the notes for Algebra 2, Section 1-1, and this is the second page of 5. The purpose of this first part up here at the top of page 2 is just to familiarize you with 4 of the shapes that we're going to be manipulating throughout this chapter. The first one is a linear function. You can see it makes a line. And it tells me that the y has to equal the x. Now we're going to be tilting this, moving it, flipping it around, doing all sorts of changes to it. But we have an uphill line like this. And you may be familiar with this from Algebra 1, written in the y equals slope times x, mx, plus the y-intercept, which is b. In this case, it goes to the origin, so it hits the y-axis. Let me label that at 0, and all these points fit the description right here. The y and the x equal each other. So here's the point: 1 to the right, 1 up, 1, 1, 2, 2, 3, 3, and so on. Negative 1, negative 1, negative 2, negative 2, and there's all sorts of other ones in between there, so the line just fills in. You get this line that goes 1 up, 1 over, 1 up, 1 over. That's the slope, which we label b or m. And it crosses the y-axis at 0, and that y-intercept is called b. And maybe you remember from Algebra 1, y equals mx plus b is one of the more common ways of writing the equation of a line. Okay, the next one is a parabola, and if you describe something as having this shape, you say it's parabolic. You get this by multiplying the x by itself before you get the y. So for instance, when x is 1, you get 1 times 1 would be 1, 2 times 2 would be 4, so that would be at a height of 4 right there. 3 times 3 goes all the way up to 9, and by the time you get out to 4, you go up to 16 in height. It curls back around on this side because when you take a negative value, for instance negative 2, and multiply it by itself, negative 2 times negative 2, it still turns out to be positive. Negative 2 times negative 2 is 4. Negative 3 times negative 3 is 9. So you get this curve here, and it's a very special curve. It's called a parabola. All right, then you have the absolute value function, and the absolute value is the positive version of the number. Now, if it's already positive, it does absolutely nothing to it. So on this side of the graph where the x's are positive, it's the same as this one. The x and the y are the same. So for instance, if you got 5 out, and that's your x value, your y would be the absolute value of 5, which is just 5. So it's 5 to the right and 5 up. When you come back in the other direction, and I think that would be more like 3 out and 3 up. Let me fix that. And if you go back to negative 5 over here, the absolute value of that is the positive version of negative 5, which is just 5. So you started with negative 5, but then when you take the absolute value, you get positive 5, and that puts you right up there. You're going to get this V-shaped graph anytime you see the absolute value of x. All right, then we're going to have a number of them where we have a constant number, the y equals some constant value. Here it's 1. So no matter where you are in the x direction, the y has to be 1. In other words, 1 up. So you might be 2 to the right, 1 up, 4 to the right, 1 up, nowhere to the right, 1 up, 2 to the left, 1 up, and anywhere else, the y is always equal to 1, and you get this horizontal line at a height of 1. If you change it to y equals 3, it would move up here, like so. Okay, so we're going to be moving these around. These are horizontal lines. All right, now I'm going to start another section here where I teach you about set notation and interval notation. And really what my goal here is something called set builder notation and interval notation. Now, these are going to be used extensively in the courses that you get later, past Algebra 2. But we're going to use them a lot in this course too. So let's start with set builder notation. It requires braces, sets require braces, But you're going to start by just naming the part of the line that's shaded here like you would do in, say, elementary school. And what I've got here is a set of all real numbers that are bigger than or greater than but not equal to 6. And so you can see I put an open dot at 6 to indicate that it's not part of the graph. Alright, so we would say in elementary school the x values, are the ones that are shaded here, are the numbers that are bigger than 6. Now, for set builder notation, you just make it a little more fancy. You, first of all, write down the numbers that are bigger than 6, and this arrowhead has to be shaded, like that. And then you tell me that it's a set by putting these braces around it. Now, I'm going to leave a little room here because we got more work to do to change this into set builder notation. Then you simply say we're using the variable x, and we want the x's such that, here's how you read that, you put a little line there and you have set builder notation. What this line does is it tells you which x's you're counting. In this case, it's all of the x's, the set of all x's, with the condition that you're using x's, only x's that are bigger than 6. So let me give you another example, but this time from the world of biology. We have a set in biology called animals, and there's many hundreds of thousands of different species in this group. But if you narrow it down to those animals such that they are warm-blooded, and they give live birth, they don't lay eggs, in other words, and they have hair and several other characteristics, what you're dealing with is a set of mammals. You've narrowed this group of animals by putting further information over here. And you say the set of all animals such that they have warm blood, live birth, hair. There's other stipulations, but all of these are true of mammals. You may wonder about, for instance, the dolphin, but dolphin actually has one hair. They don't lay eggs, they give live birth, and they have warm blood. Unlike a reptile like a snake or a lizard, they have warm blood. A snake will sun itself on the rock because it can't warm its own blood. It relies on the sun to do that. Okay, now in practice, you do it like you did in elementary school, and then you put these other symbols around it to get it into set builder notation. Okay, the other way to do it is called interval notation, and you start by telling me the beginning of the notation. In this case, the beginning of the interval starts at 6, and then you put a comma and you tell me where it ends. Now, if it goes forever to the right, you're going to put infinity there. Forever to the left, by the way, would be negative infinity. And then you tell me whether this is part of the group or not. You put a round parentheses when it's not part of the set, and since you can't get to infinity, it's always rounded there. Now, if I were to take this and I'm going to modify it and include the number 6, you would shade the dot. It's greater than or equal to at that point, and in the case where you're including it now, you put a square bracket around it. And that's what interval notation looks like. Now, it's important to recognize these are both x's. You don't have, like when you're doing points, an x and a y. Sometimes you actually use two y values, but you don't mix them. You don't use an x and a y when you're doing interval notation. And that ends page 2.